Hello viewers, welcome to Bhadra Academy. Once again, we are here with the CUET undergraduate program video where we are today going to take the topic of cells, EMF and internal resistance. Also, you can see our phone number here where you can contact and get your queries answered about the course fees, structures and other details of the CUET undergraduate program. So let's begin with the topic of cells, EMF and internal resistance. So you must have seen the cells. So here is a diagram of cells. First we are going to see cell, that is first is a primary cell, or it is also known as a dry cell. Then the secondary cell where you can see the electrolyte is there. So here we can see the composition, and basically if we see the definition of a cell is an electrochemical cell is a device that is capable of obtaining the electrical energy from chemical reactions and vice versa. So by doing the chemical reactions, the cell is providing us the electrical energy. So if we see the composition of this, so this is the structure of a dry cell or a primary cell where there is a metal cap which is basically the anode or the positive terminal, where you have it is connected through a carbon rod, and in the bottom you have a metal bottom which will act as a cathode, that is the negative terminal, right? And the manganese oxide is in this which is the negative electrode, and the zinc case is there which is covering this, and you have the paste of ammonium electrolyte. Okay, so together this comprises and this makes the whole dry cell or the primary cell, which is also known as the common battery, right? That is available in the market. Here you have the secondary cell where you have a liquid electrolyte solution where you have the cathode and anode, and when it is connected, so the current flows in this way, right, through a chemical reaction, and finally we get the electric energy. So this is the composition and details of cells. Now if we talk about the next concept, that is the electromotive force. So electromotive force is this: when the cell is connected through a circuit where a bulb is connected, here you can see in the schematic diagram. So basically electromotive force is defined as the electric potential produced by either the electrochemical cell or by changing the magnetic field or by any other force. Then the current is flowing through the circuit, right? And this is basically known as the electromotive force. So it is the force through which the charged particles are moving through the circuit, and that is what is known as the current, and we get the electricity. Similarly, when we talk about a cell and the EMF, so basically a cell contains the EMF that is generated, and also it has certain obstructions or the resistance that is known as the internal resistance, denoted by R. So if we see in the circuit also where the load is connected here, load resistor, so the resistance generated inside a battery to flow the current is referred to as internal resistance of that battery, that is denoted by small r. And now if we see the terminal voltage, that is the across the battery, that is known as V terminal voltage, that is given by the equation, that is the EMF that is generated by the battery and the internal resistance. But here we have to take the voltage drop, so therefore the current I into the internal resistance, and this will be the final terminal voltage that is given by the battery source, right? So therefore this was the concept about cells, EMFs and internal resistance and their applications also. So I hope that you have understood the topic. Similar videos will bring you more and more. Till then, be with us. Thank you so much.